Yeah, hi guys. Welcome to the Electronics Competitive Exam Preparation YouTube channel. So this channel is specially for the candidates who are preparing for the competitive examinations with background of electronics or electronics and communication from graduation or the post graduation related one. So in this YouTube channel, we are going to discuss about the different previous year question papers related to the electronic science, like the either it might be the public sector units, or else the GATE, or else the ES, okay, or else the national eligibility test or the state eligibility test. Okay, so different examinations previous year question paper solutions, in detail solutions we are going to see here. So all the interested candidates, subscribe the channel and then tap the bell icon and share this YouTube channel link in your respective groups, okay, who are preparing for this competitive examinations with electronics background. Okay, so in this video we are going to see the solutions to both these two questions, and after completion of both these two questions, with the help of this topic, I will give you the two more questions as an assignment. Okay, so please do those two questions as an assignment, and in the next video I will tell you the solutions of the two assignment questions. Okay, fine. So let's start this video. So it is the first question we are going to see here, and it is a GATE 2021 question, guys. That means just last year question. And if you look at this one, a circuit with an ideal op amp is shown in the figure. A pulse input voltage, okay, Vin of 20 milliseconds, that is 0 to 20 milliseconds. Duration is applied to the input, and the capacitors are initially uncharged. So that means both these two capacitors are not having any type of initial charges. Okay. So now how to solve this one is that if you look at both these two capacitors, that is 1 microfarad here and 1 microfarad here. So both these two capacitors are in parallel. So for example, let's take it as C1 and C2. If the two capacitors are in parallel, then the equivalent capacitance can be taken as a C1 plus C2. Okay, so now this circuit we can redraw as like this, and this equivalent capacitance can be taken as a 2 microfarads, and it is as usual the 10 kilo ohms, and it is the output voltage. And they given that it is, we have to treat that it is an ideal op amp. So ideal op amp means the input impedance of the ideal op amp can be taken as infinity, and obviously output impedance is equal to 0. So whenever the ideal op amp is given, means it follows the virtual ground concept. Virtual ground concept means whatever the potential is there at the non-inverting terminal or the inverting terminal, these potentials will be same. So in this given problem, the non-inverting terminal, the potential is 0 volts. Why? Because it is connected to ground, and we can take virtually at this point also grounded. That means we can take at the inverting terminal also 0 volts we can take. Fine. So now how we have to deal this one is that, let's take some amount of current is flowing through this one, and it is IC, and here the some amount of current flowing through this one, let's take it as a IF. So it is a capacitor current and it is the feedback current. And actually whatever the capacitor current is flowing like this, here one node is there, the current has to split up like this. Let's take it as I1. So now as per the KCL at this node, IC can be taken as a I1 plus IF, right? So IC can be taken as I1 plus IF, and whatever the I1, the current which is going through the inverting terminal, this I1 can be taken as 0. Why we are taking this one as a 0? Because the input impedance of this op amp is infinity, so that's why definitely the current becomes is equal to 0. And from this one, IC becomes is equal to IF. That means the capacitor current becomes is equal to feedback current. Got it? So now the capacitor current means, here I can write that the capacitor current is equal to C into dV by dt. Correct? So here whatever the C into dV by dt is there, I am writing like this, C into d by dt of, and this V means starting voltage minus ending voltage of this capacitor current. So starting voltage is Vn and ending voltage is virtual ground, that is 0. That is equal to, so IC is equal to IF, right? And while coming to the IF can be given as starting voltage is 0 because the IF is starting like this, and this starting voltage is 0 minus ending voltage is V0, that is here, divided by resistance, that is 10 kilo ohms. So now I got like this, C into d by dt of Vn is equal to 0 minus V0 by 10k. Okay. So now how can we represent this one? Means C dVn by dt is equal to minus V0 by 10k. And from this one we can write that V0 is equal to, let's take this 10K. Okay, whatever the 10K is mentioned, let's take this one as R. Okay, so now I can write the V0 is equal to R into C into dV in by dt. Okay, it is expression I got. So now you may check down. I got output voltage is equal to minus RC dV in by dt. That means output voltage is directly proportional to differentiation of the input voltage. That means this circuit is acting like a differentiator, or else in one condition you can also take this one as a high pass filter. Okay, fine. So here they are asking the output voltage at t is equal to 0 plus. T is equal to 0 plus means at t is equal to 0. Actually t is equal to 0 minus means just before t is equal to 0. T is equal to 0 plus means just after t is equal to 0. Okay, just after t is equal to 0 means here what is the signal is there? Okay, it is there like this. That means at t is equal to 0 plus means you will get the signal as like this. Are you understanding? The signal is like this, so you will get like this. So now it is, if you differentiate this type of signal, okay, t is equal to 0 plus means, see guys, that is equal to minus RC dV in by dt can be written as V2 minus V1 divided by T2 minus T1. Okay, so at t is equal to 0 plus, V2 is equal to 5 volts, V1 is equal to starting here 0 volts, and so T2 is equal to 0 seconds. That means same timing, right? So T2 is equal to 0 seconds and T1 also can be taken as 0 seconds. Now 5 minus 0 divided by 0 minus 0 means how much you will get? Infinity. That means I got the dV in by dt as a infinity at t is equal to 0 plus. Okay, so now V0 is equal to minus RC into infinity means you will get the output voltage is equal to infinity. Okay, so as per this calculations we got output voltage is equal to infinity, but in the realistic case we don't get output as a infinity. So what is the maximum voltage we can get from the op amp means either it might be the plus Vsat or else the minus Vsat. But anyhow here we are having the V0 is equal to minus RC into dV in by dt. That means minus RC into infinity. That means V0 is equal to how much we'll get? Minus infinity. Okay, so V0 is equal to minus infinity means we can expect the minus 12 volts is the maximum. So here answer is the minus 12 volts. All of you understood? So it is how we can solve this question. Okay, so if you did not understand clearly, so just revise this video once again. Okay, even though after revising also you did not understand means put one comment in the comment section, then we will discuss clearly in the next video. And it is the next question, NTA UGC net exam 2019 question guys, and it is a circuit given and they are asking to find out the V0. So by default you have to treat that it is an ideal op amp. So for the ideal op amp, input impedance is equal to infinity, and whatever the potential maintains at the non-inverting terminal, the same potential also maintains at the inverting terminal. Let's take at both these two terminals the V1 potential is there. Okay, and now let's take some amount of current is coming here, I1 it is, and the feedback resistor I2 it is, and in this resistance let's take I3, and in this resistance let's take I4. Okay, so these are the different currents, and whatever the current flowing through this branch and this branch, that means through the inverting terminal and the non-inverting terminal, both these two can be taken as 0 amperes, because as I already told that for the ideal op amp the input impedance is infinity and the current flowing through this one and through this one will be 0. So now if it is 0, then we can write that I1 is equal to I2, because this I1 directly flows through here, and I3 becomes is equal to I4. Correct? I3 becomes is equal to I4. Now while coming to the expression, so how can we write the expressions for this one means, so I1 is nothing but starting voltage is VA and ending voltage is V1. So VA minus V1 divided by resistance, that is 20K is equal to, and I2 can be given as a V1 minus V0. So at this point V1, so starting voltage is V1, ending voltage is V0, and in between both these two the resistance is 100K. Okay, and by simplifying this one, K gets cancels, and this one, and here 5. So by doing the cross multiplication, so we'll get as like this after doing the cross multiplication, that is 5VA plus V0 by 6 is equal to V1. Okay, and now from both these two paths we can take the I3 is equal to I4. So I3 is equal to I4, and I3 can be given as starting voltage minus ending voltage divided by 20k is equal to, and I4, the starting voltage is V1, ending voltage is ground here, so we can take V1 minus 0 divided by 20k, and by simplification we'll get VB is equal to 2V1 and V1 is equal to VB by 2. Okay, so we'll get as like this. Got it? And now whatever the V1 we got here, so let's substitute here, and after substitution, we'll get as like this. In the place of V1 we substitute the VB by 2, and then just to do the simplification, okay, and do the cross multiplication, then 5VA plus V0 is equal to 3VB. Okay, so we can take that from this one, V0 is equal to minus 5VA plus 3VB. So V0 is equal to minus 5VA plus 3VB means we can take option 4 as a correct answer. Okay, so I hope all of you understood the procedure here. So how we solved this one. Okay, so how come the I1 is equal to I2 and how come the I3 is equal to I4. Okay, and how we need to take the expressions. Fine. So now with the help of both these two, that means whatever the topics we discussed now, that means this question as well as the previous question. Just a minute. Yeah, so with the help of both these two question concept, whatever we discussed, I am requesting you to solve this question. So please pause the video and then note down this question. So this question is also GATE 2021 question. Okay, so make a note of this question, and along with this one also. Pause the video and then make a note of this question. Okay, so it is also GATE 2021 question. Fine. So take both these two questions as an assignment and try to solve these questions, guys. So in the next video I will tell you the solutions for both these two questions. Okay, so take this one as a practice, and whatever the concept we did right now, so use the same concept and try to solve out these problems. Okay, and yeah, so once again I'm telling that please subscribe the channel to get the more updates, and then tap the bell icon, and few more questions of the different examinations also I will cover in the upcoming videos. Okay, so thank you very much, guys, and if you did not understand anything whatever we discussed in this video, then please mention in the comment section. Those doubts I will clarify in the next video. Okay, fine, guys. So thank you very much, and all the best to the candidates who are preparing for the competitive examinations. Bye, guys.